Hello everyone, welcome back to the channel Battleverse, where we explore the most advanced military technologies shaping the future of warfare. Today's topic is unlike anything we've covered before because it's not just another missile system or a bigger gun, it's something that could rewrite the rules of combat entirely. No missiles. No warning. Just pure, silent, unstoppable energy at the speed of light. This is the US Navy's new laser weapon, and it may be the single most important shift in naval warfare in decades. At first glance, it doesn't even look like a weapon that could dominate the battlefield. If you were standing on the deck of a Navy destroyer or amphibious assault ship equipped with it, you might mistake it for a radar dome or some kind of optical sensor system. The main structure is compact and streamlined, designed to blend into the ship's silhouette. The weapon sits on a rotating turret, protected by armored panels and sealed against the harsh saltwater environment. Cooling vents and heat dispersal systems are built into its base, because firing a high-powered laser beam generates enormous thermal loads that have to be managed instantly to prevent damage. It's not about looking intimidating, it's about being effective without revealing its capabilities until the moment it strikes. Step inside the ship and you'll find the nerve center of the system. The control room looks like a cross between a gaming setup and an advanced space mission station. Operators sit at ergonomic chairs, facing multiple screens that display real-time targeting data, infrared feeds, radar overlays, and weapon status. Control sticks with ultra-precise sensors allow them to guide the laser manually if needed, but most of the time, the targeting software does the work. Once a potential threat is detected, whether it's a drone, a small fast attack craft, or even an incoming missile, the system locks on, calculates the perfect aim point, and delivers a focused beam with zero delay. The actual laser generator and its power conditioning equipment are buried deep within the ship's interior, directly connected to the ship's power grid. No crates of missiles. No storage for explosive shells. Ammunition is simply electricity, generated on demand. The performance of this system is what truly makes it revolutionary. Unlike missiles, which have travel time, or bullets, which can miss due to wind, range, or evasive maneuvers, the laser beam hits at the speed of light. Once the operator presses the trigger, the target is struck instantly. There's no visible flash or long streak in the sky, just a concentrated beam of energy that the naked eye may never see. In demonstrations, the laser has sliced through drones in seconds, melted the engines of small boats without detonating them, and even disabled the optics on surveillance systems without destroying the entire structure. This precision means it can neutralize a threat without unnecessary collateral damage. Imagine a swarm of enemy drones approaching a Navy destroyer. In the past, this would require either rapid-fire guns or a flurry of expensive missiles, with each shot costing hundreds of thousands or even millions of dollars. Now, the laser can engage each target for just a few dollars worth of electrical power. The ship doesn't run out of ammunition because the ammo is generated continuously from its own systems. This unlimited magazine makes the weapon particularly powerful in prolonged engagements, where resupply might be impossible. But with great power comes the need for great safety, and the Navy has built in multiple layers of protection. The weapon will not fire unless the target has been positively identified as hostile through multiple confirmation systems, drastically reducing the risk of friendly fire. The beam's power level is adjustable, meaning it can be tuned to disable rather than destroy if the situation calls for it. Automatic thermal shutdown systems kick in if the laser or its power modules overheat, preventing damage to the ship or crew. Because there are no explosive warheads stored on board for this weapon, the risk of catastrophic chain reactions from enemy hits is greatly reduced. And finally, the system is designed to operate only within designated safe firing arcs to avoid damaging the ship's own structures or nearby Allied vessels. The unique advantages of this system over traditional weapons are almost too many to count. The speed of engagement is unmatched, nothing can move faster than light. The cost savings are enormous. Think of the difference between spending millions to take down a target and spending a few dollars to achieve the same result. Its precision allows the Navy to take out specific components of a target instead of destroying it entirely, which can be critical in situations where you want to stop a threat without escalating a conflict. It's also versatile, able to deal with drones, missiles, small boats, aircraft, and even certain types of artillery shells. And because the beam is silent and invisible under most conditions, the enemy often won't realize what happened until it's too late. Of course, building such a weapon wasn't cheap. The Navy has spent hundreds of millions of dollars over years of research, testing, and refinement to get the laser to operational readiness. The installation cost per ship is significant, often in the tens of millions, due to the need for specialized power generation and cooling systems. But over the life of the weapon, those initial costs are more than offset by the massive savings in ammunition. A single missile interceptor might cost well over $1 million, and in a high-intensity conflict, ships can run through dozens of them in a matter of hours. The laser replaces that entire logistical burden with a weapon that can fire as long as the ship has power. If we think about what this means for future warfare, the implications are huge. Traditionally, naval dominance has been about who can project the most firepower over the longest range. Battleships of the early 20th century relied on massive guns, while modern ships rely on missile systems capable of striking targets hundreds of miles away. The laser changes this dynamic by introducing a weapon that can instantly intercept threats, creating a nearly impenetrable defensive bubble around a ship. This could force adversaries to rethink their tactics entirely. Swarm attacks, which are becoming more common in military strategy, may lose their effectiveness against a ship armed with a rapid-tracking, unlimited ammo laser system. In a real-world scenario, picture a U.S. Navy destroyer patrolling a contested sea lane. Intelligence reports suggest hostile forces are preparing to test its defenses by launching multiple drones and small boats in a coordinated harassment attempt. In the past, the destroyer might have had to fire off valuable missile interceptors and even engage in risky close-range gunfire. Now, the laser calmly picks off each threat one by one. Operators see them appear on their targeting screens, lock onto the closest or fastest-moving ones, and within seconds, beams of invisible energy have disabled engines, fried control electronics, or outright destroyed them. Not a single missile is fired. Not a single shell is loaded. The ship's stores of ammunition remain untouched for when they're truly needed. Another advantage is how this technology impacts logistics and strategy in long-term operations. In distant waters, resupplying a warship with missiles and shells requires coordination, vulnerable supply ships, and favorable weather. A laser-armed vessel needs only to ensure its power systems are maintained, and that can be achieved with the ship's onboard resources. This self-sufficiency could allow the Navy to keep ships on station longer, with fewer vulnerabilities. We also have to consider the psychological effect. Knowing that a ship can engage targets instantly, without warning, and without running out of ammo changes the way an enemy approaches it. It's not just about firepower, it's about deterrence. Adversaries may think twice before sending in assets that could be destroyed before they even know they're under attack. There are, of course, limitations. Lasers are line-of-sight weapons, meaning they can't hit targets hidden behind terrain or the curvature of the Earth. Atmospheric conditions like heavy rain, fog, or dust can reduce effectiveness, though advances in beam control are mitigating these factors. Power demands are also significant, meaning the ship must have robust generators to keep the weapon operational during high-intensity use. But even with these considerations, the benefits far outweigh the drawbacks in most naval scenarios. In conclusion, the U.S. Navy's new laser weapon is more than just a new tool, it's a paradigm shift. For centuries, naval warfare has evolved through bigger guns, faster projectiles, and longer-range missiles. Now we are entering the era of directed energy, where ships can defend themselves with beams of light that never run out, strike instantly, and do so for a fraction of the cost of traditional weapons. It's silent, it's precise, and it's almost impossible to counter with today's technology. While other nations will undoubtedly develop their own systems, the U.S. Navy has taken a commanding lead in this field. The days of missile duels at sea may soon give way to battles fought in the blink of an eye, where the first to fire a beam of light decides the outcome. No missiles. No warning. Just a weapon that changes everything the moment it's switched on.